When you see those incredible pictures from Mars, you're looking at the work of some of the most sophisticated robots ever created. But there's a hidden story here. Because under the hood, every single piece of these rovers is a custom-built answer to a problem that just doesn't exist here on Earth. Let's dive in.
And it all kind of starts with a really simple question. Have you ever wondered why these multi-billion-dollar rovers don't just use regular old rubber tires? I mean, we use them for literally everything here. The answer tells you everything you need to know about just how alien and how brutal Mars really is.
Okay, so there are three huge reasons why rubber is a total non-starter. First up, the cold. We're talking temperatures that drop to minus 125 Celsius. At that point, rubber doesn't flex. It shatters like glass. Second, the radiation. Mars has a super thin atmosphere, so the surface gets absolutely baked by UV rays that would chew up rubber in no time. And finally, the obvious one. You get a flat, and what are you going to do? The nearest mechanic is millions of miles away.
So if rubber's out, what's the plan? Well, before you can design a new wheel, you have to know what you're up against. And the surface of Mars, let me tell you, it is an absolute wheel breaker.
See, the ground there isn't really soil or sand, not like we think of it. The technical term is regolith, and you can basically think of it as a messy, unpredictable layer of broken rocks, superfine dust, and sharp bits that have been created over billions of years of meteorite impacts. This is the obstacle course the rovers have to navigate.
And this stuff is just plain nasty for a robot. It's full of razor-sharp rocks that can literally shred metal. And then you've got these deep patches of fine, powdery dust that are like quicksand for a rover. We actually learned this the hard way with the Curiosity rover. Its aluminum wheels took an absolute beating over the years. We're talking serious rips and holes.
But here's the beautiful thing about engineering, right? Every failure is a lesson. And all that damage to Curiosity's wheels, it became the exact blueprint for how to build the next generation better, stronger, and smarter. It led to a total reinvention of the wheel.
And you can really see that evolution right here. This is a great side-by-side. On the left, that's Curiosity's wheel design. On the right, Perseverance's. You can spot the differences right away, can't you? The new wheel is a little narrower, but the aluminum skin itself is thicker. And just look at the treads. Engineers call them grousers. The pattern is completely different.
So let's break that down. The Perseverance wheels are a tiny bit bigger, but the real magic is in the treads. Curiosity had 24 of those V-shaped chevrons. Perseverance has double that, 48 gently curved treads. And it turns out that design is way more durable against sharp rocks, but gives it just as good a grip. Oh, and those little holes on Curiosity's wheel? That was a cool little Easter egg. They spelled out JPL and Morse code to track distance, but Perseverance's cameras are so advanced they just don't need them anymore.
But get this, even as NASA was perfecting the aluminum wheel, another revolution was already starting in the lab. It kicked off when a materials engineer at NASA, Santo Padula, saw the pictures of those beat-up wheels and basically told his team, hey, I think I've got something for that.
And his solution is something straight out of science fiction. It's called a shape memory alloy, or SMA. It's this incredible nickel-titanium material that, well, it has a memory. You can bend it, crush it, completely deform it, and it just springs right back to its original shape, no damage done. This stuff can handle 30 times more strain than the materials on the rovers today.
And the advantages are just a total game changer. An SMA tire is basically a mesh, so it can't be punctured. There's no air, so its performance never changes. A rover could roll over a razor-sharp rock, the wheel could totally flatten out, and then just pop right back into shape on the other side. And because the mesh is the structure, they're super lightweight. This isn't just an improvement, it's a huge leap forward.
All right, so the wheel problem is well on its way to being solved. But the Martian environment, it has other ways of attacking a rover, more subtle ways. It's not just the rocks and sand you have to worry about. It's the invisible killers, the dust and the atmosphere itself.
Okay, so Martian dust isn't like the dust bunnies under your couch. It's incredibly fine, almost like flour. But here's the kicker. It's electrostatically charged, so it has this almost magnetic attraction. It clings to everything, which creates massive headaches for any kind of machine.
And this sticky dust is a menace in so many ways. It coats the solar panels, which basically chokes off the rover's power supply. It gets into every moving part, grinding away at the machinery. It can even mess with the communication antennas and the radiators that keep the rover's electronics from overheating.
Now, you're probably thinking, well, Mars has those famous winds, right? Can't they just blow the dust off? And this is where our Earth intuition completely fails us.
Winds on Mars can hit hurricane speeds, over 100 miles per hour. But because the atmosphere is so incredibly thin, all that wind only has the force of a gentle 12-mile-per-hour breeze here on Earth. It's nowhere near strong enough to clean anything.
But here's a fascinating twist. That same thin atmosphere that makes the wind so weak, it's actually a huge help for protecting the rover's sensitive electronics. On Earth, it takes around 7,000 volts of static electricity to create a spark. On Mars, because that thin atmosphere is so easy to ionize, it only takes about 400 volts. This means static can't build up to dangerously high levels before it safely discharges, protecting the rover's computer brain from a fatal shock.
So how in the world do you account for all of these bizarre, interconnected challenges? How do you build a machine to survive in a place where all the rules are different? The answer is simple, but it's incredibly hard. You do it through relentless, meticulous testing. And this is what that looks like. This is basically a torture chamber for rover wheels. NASA built this incredibly complex machine to simulate all the forces a wheel will face on Mars. Giant hydraulic presses push and pull on it, mimicking everything from the jolt of landing to the strain of climbing a sharp rock. They leave absolutely nothing to chance. And this right here, this is the power of modern engineering. On the left, that's a 3D scan of the real wheel bending under stress in the lab. On the right, that's the computer simulation, predicting what would happen. And they are virtually identical. This is how engineers know their design is going to work when it's millions of miles from the nearest help.
Now, this process has a technical name. It's called test analysis correlation. But really, all it means is making sure your computer models perfectly match what happens in the real world. When they line up like this, engineers can be confident that their designs will survive the real thing on Mars.
So when you boil it all down, here's the key takeaway. Nothing on a Mars rover is off the shelf. The wheels, the power systems, the computer, every single component is a custom-built, one-of-a-kind solution to a problem that only exists on Mars. These machines are the ultimate expression of engineering for survival. We've built these absolutely incredible machines that are engineered to survive. Which leads to one last thought, right? What new engineering marvels will it take to build the machines that don't just help a robot survive on Mars, but help humans one day actually thrive there? Now that is the next great challenge.